Good morning, everyone. Today we are present here to present our PPT of Python project on virtual power electronics lab. My name is Mohit Jain Raut. I am from SY Electrical Department. Next slide. Introduction contents. So our content in PPT are first is the introduction, second is the methodology, third is the components required, fourth is the flowchart of our code and project, fifth is the working, sixth is the result, conclusion and references. First, so introduction. Basically, we are presenting our model to make the virtual power electronics lab using Python programming. The primary objective is to provide interactive or GUI-based simulation for platform for key experiments in power electronics such as half-wave rectifier, full-wave rectifier, buck converter, boost converter, and inverter. It uses Python, tkinter for GUI, matplot library for graphical plotting, and built-in logic to simulate basic circuit diagram behavior. This eliminates the need of for physical hardware, making it soft, if it's so effective and accessible for remote learning and prototyping. So further methodology will be presented by my fellow teammate Pawan Kamde.
Good morning, everyone. Here I am presenting my slides of methodology. Uh, in methodology, the coding designs approaches used in the virtual lab, which is based on Tinker for creating interactive windows, buttons, and menus, and Matplotlib for displaying input-output voltage waveforms. And another is modular programming. Modular design, each experiment is implemented as a separate function. And in Python, exception handling used to ensure smooth user experience and error-free simulations. And it also uses OOPS, which is optional but potential for future scalability to convert into full object-oriented design. Next slide will be explained by Pawan Kamre.
Good morning, everyone. My name is Pawan Kamde from SY Electrical Department. So the component required Python latest version preferred 64.4-bit, and second is Tinker library, and third is Matplotlib library for the graph presentation, and the most important is Python IDLE. So this is the flowchart of the code. First, we are opening our window where our college name is there and power electronic lab. Then we can say proceed button, and the list of experiment will listed out. Then we have to select the experiment which we have to take. For example, if we take experiment number 1, it will open the circuit name, theory, and etc. All the details of the experiment particularly of that we have selected. And after clicking that, we have to enter the observation table. Then the graph will be plotted. Hence, our experiment is successfully done.
Simulation.
So good morning, everyone. This is the code of our project, that is the Python Electronic Virtual Lab. So we have used here three libraries, that is Tinker, Matplotlib, and also in additional Matplotlib library for image generation. So in starting code, we have set up the all the GUI, that is our interference, that what theme it should have and what background it should have. Scroll down. Scroll. So in this, we have defined a function where we have mentioned the experiment name, list, and figures, and graph we have input y functions. So, okay, this one is for this function, that is the show observation table, is for the observation input. We have to input the values for voltage and time, like time or anything that we have to input, and we will get a graph of using Matplotlib library. Scroll down. Okay, in this we have talked about the waveform and the graphical representation of our experiments. Here, different types of graphs are used, like for experiment half wave, full wave, inverter, boost rectifiers. Here is the list of our 5 experiments that we have added: inverter, boost, buck, and half and full wave. Niche. This is an experiment selection window, and the aim and theory of the experiment is been listed down. Like we have input this to the print statement. Uh, नीचे कर. Okay, so here we have implement a canvas, like like a homo geometry it should have, and what should be interference with it, like header, display, the notice, and what would be the size of our GUI. Niche. Okay, so this is like the end. We have to just give the geometry of canvas, its size, and mention. And the next part of simulation will be explained by Priyanshu Poddar.
Some examples output from our lab. You can clearly see the waveform for different converters and rectifiers. This really helps understand how circuit behaves without touching a breadboard. Internally, when an experiment is selected, the system dynamically loads relevant circuit diagrams and uses mathematical codes to simulate its behavior, which is then plotted graphically. Here we can see that our first slide is of Department of Electrical Engineering. Then we will start a tab. Aim comes near us, where first aim is given, then theory, then advantages and disadvantages of particular aim. Next slide. These are the circuit diagram of particular aim. For example, we have seen here the waveform of full wave converter, full wave rectifier.
My name is Ayush Meher. So I am here to explain about conclusion. We developed virtual power electronic lab, which was GUI-based alternative to physical circuit building. It was cost-free and portable experiment simulation. We have easily visualized input and output waveform for better understanding, reusability and expandability for more complex experiments. It acts as fundamental learning tool for students and research alike in understanding basic power electronics system interactively. So thank you.